All right, we're just going to get right into going over the any questions you may have. We're just going to go page by page. And also as I looked at all this and we still have possible questions on the FRQ, I'm going to just go over the non-calculator today. I'll go over the calculator and FRQ stuff tomorrow. And then we're going to test on Friday on the non-calculator and on Tuesday on the calculator. Okay, so I'm just going to adjust that by a day as far as when we're testing. All right, so let's just go page one, numbers 1 through 5. Fire away.
Could you do 3, please?
Yes. All right, number 3 says big F of X, excuse me, big F of X is equal to the integral 2 to X 3t dt. If that is true, then an equation of the line tangent is at the point X equals 2 is what? Okay, so to write the equation of a tangent line, we need a point and a slope. Okay, we have the X coordinate of the point, which is 2. We need the Y coordinate, which means plug 2 into F of X. So to get the Y coordinate, F of 2 is equal to the integral 2 to 2, 3t dt. And we know when we're integrating on anything to itself, that is equal to 0. So we have the point 2, 0. Okay, now we need a slope. Okay, to find the slope, we need to find f prime of 2. Well, first we need f prime of x. So f prime of x is, this is the fundamental theorem of calculus part 2, okay, which is just plug this x into here. So f prime of x is 3x. Now I need to find f prime of 2, which is 3 times 2, which is 6. So I have a point, obviously, I have a point and I have a slope. So now to write the equation, I'm going to go to point slope form first and then adjust from there. Okay, so we have y minus y1 is equal to m times x minus x1. And then I go look and see if that's on there, and it is. It's answer choice C. And maybe they might be written in slope intercept, which this is in slope intercept also because of that 0. Maybe they're written in standard form where we got to move x's and y's to one side. You just got to adjust to whatever the answer may be. All right, any others on page 1?
Number 2.
Number 2 says let y equal the integral x to 2x tan t dt. Okay, so this is the fundamental theorem of calculus part 2 and part 1. Okay, we got to plug both of these in there. So we got to do f of b minus f of a. So we're plugging 2x in. And so that's the tangent of 2x. But we have to do a chain rule on that. And the derivative of 2x is 2 minus, we're going to plug an x in, tan x. So 2 tan 2x minus tan x is answer choice B.
On number 1, do you just plug in x? Is that all you had to do?
Yes, that is correct. That's the fundamental theorem of calculus part 2. Okay, so if this is f of x, then the derivative is plug that in, plug that x in. Now, if that says x squared, 2x, some other function other than just x, then you got to plug it in and do a chain rule.
Okay.
But we're not doing the fundamental, we're not evaluating it. We're just finding f prime of x. Evaluating it would be then plugging, doing all this stuff where we're plugging -1 in and all that. All right, anybody for 4 or 5, average value? Both of them are the same, basically.
Could you do 4, please?
Yes, all right, so this is f of x. To find the average value, it's 1 over b minus a, integral a to b f of x dx, okay? So we're going to do 1 over, we're going from 0 to 8, that's our a, that's our b, so 1 over 8 minus 0, and then the integral 0 to 8 And then I got to rewrite this because I do not know how to take the antiderivative of the cube root of x squared, but I do know how to take the antiderivative of x to the 2/3. Okay, so I rewrite that as so. And now it's take antiderivative. We will evaluate this. So this is 1/8. And then my antiderivative is add 1. So I get x to the 1 is 3/3. So I get x to the 5/3. And then divide by 5/3, which means multiply by 3/5. And we're going to do that from 0 to 8. All right, so this part I'm going to do in my head. Okay, when I'm raising something to the 5/3, okay, so x to the 5/3 means the cube root of x to the 5th. Okay, it doesn't matter if you cube root first and then raise it to the 5th, or take the 5th power of it and then, raise it to the 5th and take the cube root, or take the cube root first and then raise to the 5th. Okay, it just all depends on the numbers. Okay, so when I'm plugging in an 8, okay, I'm not going to raise 8 to the 5th first, because without a calculator, I don't know what that is, but I can do the cube root of 8. So the cube root of 8 is 2. Now I'm going to do 2 to the 5th, which is 32. And now I have to multiply that by 3/5. So 32 times 3/5 is 96/5. Minus 1/8 and plug a 0 in. And when I plug a 0 in, I get 0. So it's really just this right here, which is 96/40. But 8 actually divides into 96 evenly. The best way to do it is to start going by 2s, right? 2 goes into 8 4 times. 2 goes into 96 48 times. Now I can see 4 goes into 48 12 times. So I get 12/5. All right, anybody for 5?
Could you, for 5, could you do the 1 over b minus a part? Because I just can't get that.
Yep, this is A, this is B, right? So it's pi over 2 minus pi over 4. Change pi over 2 to be 2 pi over 4. So 2 pi over 4 minus pi over 4 is 1 over 1 pi over 4. And when I'm dividing by a fraction, just flip that thing and multiply by the top. So it's 1 times 4 over pi. So I get 4 over pi for the 1 over b minus a part. And then you're going to multiply that by the integral pi fourths, pi halves, cosine x dx. And the antiderivative of cosine is sine. And we're doing that from pi fourths to pi halves. So I would not distribute. I would just do this. 4 over pi, and then f of a minus f of b. So the sine of pi halves is 1, and the sine of pi fourths is negative radical 2 over 2. And I believe that is good enough for an answer because it's free response. It's not multiple choice. So we'll stop there. We do have to evaluate. So we can't just leave it like this.
Mr. Masson,
Yes.
wouldn't it be, because aren't you supposed to subtract it? So it'd be, or it's positive, radical 2 over 2. Oh, because
Yeah.
never mind, I got it.
All right, that covers page 1. Let's go to page 2. All right, we're given the graph of f, and we're given big H of x is equal to the integral 0 to x f of t dt. All of questions 6 through 12 are on this graph, so fire away. First thing, by the way, I would write is this is f, which equals big H prime.
Could you do 10, please?
Yes. Okay. So number 10 is saying is H of 8 positive or negative. So H of 8 is the integral from 0 to 8 f of t dt. I am not going to be able to get an actual number from this. Okay. It's not possible because this curves and I don't know geometric formulas to find the area of that. Okay. This is a straight line from 0 to 2. And then it looks like it's quadratic attached to it on the other end. We can't call it a quadratic, but it looks like one. Okay. But here's what I do know. Whatever the area of this is, which is positive, plus whatever the area of this is, which is negative, this is bigger than this. Okay. And you could count squares. You could say I have like 2, 3, 3.5, 4.5, 5.5. You know, you could just start doing that. And you can start counting these and you can see that this is definitely bigger than this. So the area is going to be negative. Now, I didn't write on the paper, but I'll show you what I wrote on mine is I wrote this. Clearly, the area under the curve is bigger below the x-axis than above the x-axis. Therefore, it's negative. And that's all we can say there, okay? This might be a good enough explanation, but I don't really think so, okay? Because yeah, all you're doing is stating it's negative. So you do need to explain by saying the area below the x-axis is bigger than the area above the x-axis. Doesn't matter how you word it, but something on those lines. And then that's a good enough explanation. There's really no work to show it there as far as algebra goes. All right, any others on this page? All right, we'll move on. You guys are making it so I'm going to change my mind and make the test be Thursday and Friday. Flying through this. All right, this is again a graph and it covers all questions 13 through 18. This is a velocity graph. And we're probably going to be asked a lot of things about acceleration and or place, position and distance. Fire away.
18, please.
18?
Yeah.
All right, so 18 says, during the time interval 0 to 9, what is the greatest distance between the bug and the origin? Show the work that leads to that. Well, greatest distance is just an EVT question, okay? It's just furthest away, maximum distance away. So EVT says we need to check endpoints, so we got to check 0, and we got to check, I can't read that number, what is that, 6, 7, 8, so that's a 9. That's 0, that's 9. And any critical numbers in between. A critical number is where the velocity is equal to 0 or undefined, okay? So right here. So this is at 7. So in my table, I got t, and I got, I'm just going to say distance from the origin because I don't have the name of the position function. But what you have to keep in mind is we started at 1. Okay, the position at time 0 is 1. So at time 0, I'm 1 unit away from the origin. Okay, way back up in number 13, we found this to be 15 minus pi over 2. And that was from 0 to, that's actually, I don't even need that answer. What answer do I need? I know this is 15, and I know this is negative pi over 2 down here. Okay, area of this semicircle is pi over 2. It's negative. The area of this trapezoid is 15. Okay, so from 0 to 7, so I didn't write it out on the answer key, but what I'm doing here is I'm integrating from 0 to 7 v of t dt. Okay, but remember, we're starting at 1, and from 0 to 7, we went a total of 15. So I'm going to add 15 to that, and so that is 16. And then from 0 to 9, I started at 1. I add the 15 from 0 to 7, and I subtract the pi over 2 from 7 to 9. And that gives me a total of 16 minus pi over 2. And really what I did on this one is I integrated 0 to 9 v of t dt, and then I added in my initial value.
So you say you start at 1 because at the top it says the position is x equals 1?
At time 0, yes, because at time 0, the position is 1.
Okay. I was confused with that. I didn't read. I was like, wouldn't you just be at 0?
Right. Remember, this is not the graph of position. So even though this point is at 0, 0, on position, we're at 0, 1. Remember, we're not looking at the graph of what they're asking us. We don't even know what that graph looks like. Okay. And that's the tricky part, because people want to say at time 0, this is not the actual, what is this, a bug? This is not the actual bug walking. Okay. This is a relationship of time and distance, right? Okay. But it's not the position at that time. Okay. This is the relationship of velocity in time, not position in time. Okay. So all we're seeing is velocity.
Okay.
All right. Any others? And then, you had to explain it. The greatest distance is 16. 16 is bigger than 16 minus pi over 2. Okay. They're going to make it so it's easy numbers that you can look at, that you don't have to really compare too hard. All right. Any others in this section?
Can you explain 15?
Yes. When is the bug slowing down? The bug is slowing down, okay, when velocity and acceleration have opposite signs. It's no different than me asking you, is the speed increasing or decreasing? Okay. And that's when velocity and acceleration have opposite signs. So what I'm going to do is I'm going to look at this graph. Okay. This is the graph of velocity. The graph of acceleration, which I don't have, is just the slopes of this. So from 0 to 7, my velocity is positive. From 0 to whatever this number is right here, 3, my acceleration is positive because my slope is positive here. Okay. So velocity and acceleration there have the same sign. Here, velocity is positive and acceleration is 0. They don't have opposite signs. Okay. Now from here to here, velocity is still positive. We're above the x-axis, but acceleration is negative because we have a negative slope. So that's going from 6 to 7. Okay. Now down here, velocity is negative from 7 to 8. Okay. We're below the x-axis, 7 to 8. And my slopes on all these are negative, right? Because our tangent lines would be on this bottom side. Okay. But from 8 to 9, my velocity is still negative, but now the slopes of my tangents are positive. So therefore, from 8 to 9 also. Okay, make sense? Once it's explained once, right? Is you got to compare velocity and acceleration. And then explain it's when velocity and acceleration have opposite signs. You have to state that. You can't just put the interval. All right, we good there? Let's go ahead and hit the integrals. All right, so this page has got indefinite and still indefinite on the next page. So we'll just do all this, 19 through 24. And they're going to be all mixed up now, right? So you got to be able to recognize inverse trig ones. You got to recognize U substitution ones. There's really no basic straightforward ones in this section. We did that last test. We're good?
Can you do 19, please?
Yes. All right. So 19 says 4x times the cosine of x squared. Again, we do not know the antiderivative of a product. Okay. So I find my composition function, or the one that gives me the chain, and that's cosine x squared. That's a chain. And the inside is my u. So u is equal to x squared. Du over this derivative, which is 2x, is dx. Okay, so once I get my dx, I'm going to go back and substitute. It's the integral 4x times the cosine of u du over 2x. And we have to get functions. Constants are okay to keep, but we have to get functions to cancel. Okay. And this X cancels with this X, and this 4 and this 2 reduced to be a 2 up here. Okay. So that's a constant multiple now. So I'm just going to pull the 2 out. And now all I have left inside is the antiderivative of cosine of u. The antiderivative of cosine is sine u, and u was x squared. And since it's an indefinite integral, plus c. And if you think about it, if I were to take the derivative of this, right, d dx of 2 sine x squared, okay, we keep the 2, okay, because it's a constant multiple. The derivative of sine is cosine, leave your x squared. Chain rule, derivative of x squared is 2x. There's your 4x, and there's your cosine x squared, just like we started with. Okay, so if you know how to take a derivative, you should be able to go back to find whatever the antiderivative is. Once you get your antiderivative, you can check it. All right, any others on this page?
Can you do 20?
Yep. All right, so 20 is of the form, we pull this 2 out, and it's of the form 1 over a squared plus u squared. Okay, so I'm going to pull this 2 out, and I'm going to have the integral 1 over 1 squared plus x squared dx. Okay, so then this is an arc tan, inverse tan one, right? And inverse tan is 1 over a. A is, so in this problem, a is 1 and u is x. So it's 1 over a, which is just 1 over 1. So I'm not going to write that. Arc tan or inverse tan, whichever one you prefer to write. And then it's x or x over a or u over a. So it's x over a, and a is 1, so it's x, and then just your plus c. All right, any others?
23.
All right, 23. All right, so the first thing I'm going to notice about 23 is there's two things. Obviously, I have a function up top and a function on the bottom, and I don't know the antiderivative of a quotient. Okay, so we got to do u substitution, or maybe it's one of those special 1 over u's, or maybe it's one of those inverse trig ones. Okay, I don't know which one it is yet, but I'm looking at this. Okay, now to determine if it's the inverse trig one, I'm going to look at this and I'm going to say, is this of the form a squared plus u squared? Well, there's nothing squared to give me 7, nothing pretty, no pretty number to give me 7. So this is not of an inverse trig form. Okay, so now it's going to be a u substitution, and it might turn into a u on the bottom. Okay, which it is going to, right? Because I need to make 3x squared plus 7 my u. So that means I'm going to have something over u in the end. Okay, du divided by the derivative of this, and the derivative of this is 6x, is dx. And lo and behold, it's going to cancel. So this is the antiderivative 6x over u du over 6x. The 6x's will cancel, and I'm left with 1 over u. Memorized, the antiderivative of 1 over u is the natural log of the absolute value of u plus c, and my u was 3x squared plus 7. Any others?
Can you do 24, please?
Yes. All right, so 24 is definitely not of the antiderivative, excuse me, of the inverse trig ones, okay? It might be a 1 over u situation, but we'll see that. And if not, we'll go from there. But we have two functions down here on the bottom, okay? That's a product rule inside of a quotient rule, okay? We don't want to make x my u, because if I make x my u, then I'm just going to have du over 1, and that's not going to cancel the natural log of x, okay? So my u is going to be the natural log of x. I always like to do this one without skipping steps because of the whole fraction over here. So the derivative of u is du. The derivative of the natural log of x is 1 over x dx. Multiply both sides by x, and you get x du equals dx. So now I'm going to pull this 2 out. It's a constant multiple. You don't have to do that right there, by the way. I just like to. And I have 1 over x times u x du. Okay, this is in my numerator now. And these x's are going to cancel. And so I'm left with 2 times the integral 1 over u. So it's 2. The antiderivative of 1 over u is the natural log of u plus c. And u just happens to be a natural log of x. So it's 2 times the natural log of the absolute value of the natural log of x plus c. We get some funky functions when we get to calculus, right? We don't see things like that in pre-calc. All right, any others? All right, next page, 25 through 30.
$28.
28. Okay. All right. So 28 is a polynomial divided by a polynomial. And when the degree on bottom is bigger, make the bottom u. When the degree on top is equal to the degree on the bottom, or when the degree on top is bigger, then I must do long division and split this up. Okay. So I did, I believe I showed the work. I can't remember synthetic division, but you could do long. But remember, synthetic only works when this is x to the first. You put the opposite of this in a box, and then you put the coefficients 1, 1, and -7 up here. And then you bring down the first one. You multiply this one by the number in the box and write it underneath the other one, and you add instead of subtracting like you do in long division. And then you multiply here and get 12, you put it there. And then you add and you get 5. That's my remainder. So this is the function x plus 4 plus 5 over x minus 3. And so I'm just going to integrate that. Now, I have always written it as 3 separate integrals. You don't have to. You can write one integral and write x plus 4 plus 5 over x plus 3 dx, like so. And then you're just going to take the antiderivatives of each piece individually. Okay, and then this one being the only hard one. And it's not even hard. That's one of the most basic u substitutions we do. Okay, the antiderivative of x is 1/2 x squared. The antiderivative of 4 is 4x. And you would have to do a u substitution here, okay? Maybe you could do it in your head, maybe you can't. We're going to pull the 5 out. And you really just have, I'm just going to work up here. You have 1 over x plus 3. And I'm going to make u be my x plus 3. And the derivative of that is just 1. So it's du equals dx. But I'm left with 1 over u now. So I pulled the 5 out. And I have 1 over u. And the antiderivative of 1 over u is the natural log of the absolute value of u, where u was x plus 3. Nothing canceled when we did that because we didn't have to cancel anything. We just can't do the antiderivative of quotient. And now add your plus c on the end. And I think this was x minus 3 instead of x plus 3. My bad. You're slacking, Katya. You should have been on that right away.
I'm sorry.
All right. Next one on this page.
Could you do 29, please?
Yes. All right. So 29 is a product. Sine x times cosine cubed x. Okay. Don't know the antiderivative of a product. Got to make a u substitution here. And the u1 is going to be the one that is the compound. So the inside function is cosine. The outside function is x cubed. So u is cosine x. Sorry. U is cosine x. So du divided by the derivative of cosine. The derivative of cosine is negative sine. So we end up with that. And then we're going to go back over here and substitute. We have the integral sine x. And then this just becomes u cubed. And then du over negative sine x. Okay, the signs cancel. And I have this negative. I'm going to pull the negative out. And then the antiderivative of u cubed is add 1 to the exponent, divide by the new exponent. So it's 1/4 u to the 4th, and u is cosine x. And you could rewrite that, and then don't forget the plus c. And you could rewrite that as negative 1/4 cosine to the 4th x plus c. Either answer is acceptable if it's free response. Obviously, it's the multiple choice. You don't have to rewrite it. You just have to go recognize your answer. Okay. All right, next one.
$30.
All right, number 30 is I recognize that as an a squared plus a u squared. Okay. If I made my u, if I just did a u substitution and I made u 9 plus x squared, okay, don't write this down, but if I did this, then du is going to be 2x dx. And now I got this 2x in there. So my integral would be 1 over u du over 2x, and the 2x isn't going to cancel. Okay, so that got me nowhere. I have a u and I have a 2x now, and I still can't take the antiderivative of that. So I got to recognize that as being one of the inverse trig ones, okay, where it's 1 over a squared plus u squared. Okay, so my a is 3 and my u is x. Okay, the square root of 9, the square root of x squared. Okay, and you could rewrite it. I'm just not rewriting it anymore. Okay, but I will do it for you. It would be rewritten as 1 over 3 squared plus x squared dx. But I'm just writing down a and u at this point. Okay, and this is an arctan or an inverse tan one because it's not the square root one. The square root one is the sine one. Okay, so it's 1 over a, arctan or inverse tan, u over a plus c. So it's really just recognizing you're in an inverse trig form. Then it's recognizing what a and u are, and then it's memorized from there. Okay.
So dx equals 1.
No. This is like saying, this is like saying 1 over dx. So I just wrote the dx out there, but we're recognizing this as 1 over a squared plus u squared. Technically dx, yeah, equal. When you're taking the antiderivative, you just drop this.
Okay, I got it. Thank you.
That just tells you what to take the antiderivative in respect to x. All right, we good here now on this page? Get to that last page before we end here. All right, so we're just going to go up to 34 on this page. We'll do calculator and FRQ tomorrow since the calculator is shorter. So again, here we got to just be able to recognize, it looks like most of them are inverse trig. Not all of them, but most of them. Well, two out of four, I should say, are inverse trig. 2 of them are natural logs. Anybody need any of these, or was the work pretty much self-explanatory? All right, like I said, we're just going to go ahead and move the test to Friday and Tuesday. Now, keep in mind, we're not in class on Monday. Okay, there's no school Monday, so you're going to go 3 days and then have to take the calculator portion of the test. Okay, but Friday we'll do the non-calc, and then Tuesday we'll do the calc. Probably be roughly, anywhere between 12 and 15 questions on each part. Okay, and we'll move on to the next section. But tomorrow we will Zoom, and we will do the calculator, and then go over any questions you may have had on the FRQ, and then test Friday, Tuesday. If you have no questions, have a great day, and I'll see you tomorrow.